Welcome back, NASA Hunch students and teachers. My name is Miss Brittany Koger, and I'm going to be walking you through the second investigation station for our microgravity dice game. All right, in the last station, you tested to see how far away a magnet could attract a piece of metal and see how close they could get together. That way, to protect our astronauts from attracting different things in space to our game board. We don't want that to happen. So in this test, we're going to see how thick of a material that we can print our game board out of. Our game boards are going to be printed out of a different type of 3D printed material. So a PLA, if you have 3D printers and you can print some of these, the link to the sizes is going to be there to where you can just print these. I just did little squares of different sizes and different thicknesses. I started out with the thinnest one I could get. I'm not going to tell you the size on it because I don't want you to know that. And then it went up each time in a little bit of a different thickness each time. So you're going to see how thick of that material a magnet can stick through. Now, if you do not have a 3D printer to where you can 3D print some materials, you can do this station still with some different materials that you have. You can do it with notebook paper. I would try notebook paper, try construction paper, cut them into smaller pieces. Index cards would be a really good one to try. Card stock, anything that you have that would be thick, that could pull through. If you have those plastic folders that your students might use, I cut up some pieces of those plastic folders and saw how many pieces of plastic it would go through, because that's going to be closer to our PLA material is the plastic stuff. So use whatever you can and whatever you have available to you. I will show you kind of how I did this test with my students. So you're going to need these materials. You're going to need some type of piece of metal, either a little nut or a washer, a little metal ball. I have those ball bearings, or even a paper clip. Anything metal that you can stick to a magnet. I would go with a stronger magnet, but you can test out different magnets. I have a round refrigerator magnet, bar magnet, a rare earth magnet, and a neodymium magnet that I used in the last test. You can even use wand magnets, whatever you have available to you. And you can get magnets on Amazon, Walmart, parts stores, Dollar Tree, anywhere that sells refrigerator magnets. There's magnet. So use magnets and get magnets wherever you can. So you're going to need, like I said, your ruler, your magnet, your piece of metal, and your material that you are going to be testing. And you're going to see how thick of a material that it could test through. Now, with index cards and stuff, I'm gonna go with this round magnet first. That's the one I'm gonna stick with, and I'm gonna see, can I get a piece of metal to stick through an index card? Yes. Okay. So maybe I do 2 index cards. 2 index cards. Does it still stick? Yep. Okay. Let's try 3 index cards. Still stick? Yep. 4. Oh, it slid a little bit on 4. 5. Oh, stuck. 6. 7. And keep going until you can't hold anymore, until it just falls off. I'm not going to tell you how many. I'm just going to grab a stack and I'm going to see if it'll go through that. And no. So that would be too many. I'm not going to tell you how many I got to. I just showed you 7 and it was still sticking. I want you to do this investigation and see how many it will stick through. So that's how you're going to do that. You're going to test your index cards. And then if you're doing construction paper, do the same thing. Notebook paper, same thing. Just try to see how many pieces you can get those pieces to stick through. Now, I'm going to show you the 3D printed material that I have, and I'm going to show you how we did that. So same thing. You put your metal on one side, magnet on the other. Is it sticking when I let it go? Yes, it's sticking through that first one. I would measure that to see how wide that is, and then I would write down that, yes, it stuck through that. All right, let's see if it'll stick through this one. Oh, it pulled it around the side of it. Oh, no, I'm stuck to it. All right, yes, it is sticking through this one. As you can see, it's stuck. All right, we'll try this thicker one. See if it is still sticking. Oh, no, it didn't stick on that one. Look, watch, it's trying to go around it. It went around the bottom of it. It fell off. So this one would be too thick. If you make it through all of them and it's still sticking through all of them, put them together and measure. Every time that you're doing this, you need to measure the thickness of what you just did. So this one right here is 3/8 of an inch in thickness, and that's the one that it started sliding off of. So write down and record your information. Tell me how it acted with these, how much material it stuck through. That's what we want to see. We want to see how thick our game board will need to be, because we don't want too thick of a layer of this 3D printed material between our magnet base or our metal base and our magnet. We want them to be able to stick together easily and not float off into outer space, and we want our game to work correctly. So that's why we're testing these different materials. We want to see how thick to make the inside of our game board. I hope you have fun with this. You can do this whole group, you can do this individually, you can partner them up, or small group. I did it small group, and I had them partner up in teams of 2 or 3. No more than 6 people in each group, and I had them all record their data. So I had somebody over there testing index cards while the other person was testing 3D printed material, and they were recording their data, and they worked together and collaborated that data together in the end. And all of them talked about it at the table. What did you notice? What happened to this? How many pieces? How thick was that? Did it stick right away? Did it slide a little bit? How did it react when it stuck through it? So that's what we want to see. Record that data like a scientist. That's what we want. We want to go back to this data, because this data is going to help us with our dice game design in the very end. All right, we have a couple of more investigation stations coming your way, guys. I cannot wait to see you at those later investigation stations. I hope you have fun with this and enjoy and explore how magnets work and the thickness of material magnets will stick through. If you get done with all of your material, you can see if it'll stick through your table, see if it'll stick through different things around the room, if you will allow your students to do that. Just let them have fun with this, and let them do some investigations with magnets and metal and see how thick of a material they can stick through. All right, I'll see you at the next station, guys. Have a great day.